we are going to start with problem 4, and again, we'll see how far we go. This one I think we might only get 2 problems done before we have to stop it because I don't like the videos to be super long. Um, so on this problem here, it says scatter plot shows the theater revenue and rental revenue for each of 21 movies. So they're correlating theater revenue to rental revenue and seeing if there's like a relationship between them. And they picked 21 movies to do this with. And then it says that it also has a line of best fit for the data. So they've put the line of best fit in for us, right? And if you look at it, it's a good line of best fit. It splits the data pretty evenly. And it looks like it's going up, right? So let's take this now and use what we know about linear relationships and see if we can answer this. So letter A says, for these 21 movies, as theater revenue increases, rental revenue tends to, and our choices are it it will increase, it will decrease, or it'll stay the same. So theater revenue is my X value, right? That so if you look at 0, right, it would be somewhere around, I don't know, 3 or something like that. If you go up to 10, it looks like it's at 4, and sorry, it's not 4, it's 4 million. If you go up to 20, it looks like it's getting, it's kind of halfway between 5 and 6, somewhere around there, million. If you go to 30, we're looking at close to about maybe a little more than 7 million. So it's going up. As theater revenue is going up, the rental revenue is going up. So that would be an increase, right? And then it says for these 21 movies, there is a what correlation? Well, it just think about, you basically look at the slope of your line. And if it's a positive slope, it's a positive correlation. If it's a negative slope, it's a negative correlation. So this one would be a positive correlation because it goes up from left to right. And then it says, and this is the hardest part, is using the line of best fit, we would predict that a movie generating a theater revenue of $60 million would generate a rental revenue of approximately, well, let's find 60 million for our theater revenue. Our theater revenue is our X. So if I go over to 60, I'm going to go up on my line until I hit the line of best fit. Now we have to be really clear about this. We're not going up to a data point. So I'm not going up to this point right here. I'm going up to the line of best fit. And the line of best fit's right here. And that looks to be, it's under 12, but it looks like it's more than halfway up through here, right? Like if I zoom in a little bit, right? It's definitely up there. So I'm going to look for something that's maybe like 11.5 or somewhere in that area. So let's see what my options are. Yeah, and they do have one that's 11.5. So I'm going to pick that one. And the others are clearly not even near it. So that's how that works, right? Just use the information they give you and just try to answer the questions. Not too complicated. Now this next one, we're gonna be doing some math here. All right. And this one, I remember going through this in class, tended to give people a little more difficult of a time. But it's just a matter of trying to reason this out. Okay. So we've got another scatter plot. It's comparing average monthly temperature in Fahrenheit degrees. That's what we use here for the most part, compared to monthly heating costs. And now before we look at this, just think about this. As it gets warmer, and especially people who live in the Midwest like us, your heating costs, of course, are going to go down because you don't need to heat your house as much. In the winter, that's when we're cranking the heat and it's cold, and we want it warm in the house, and so obviously that costs more because you're using more fuel. So this is going to have a negative, right? It's a negative association, a negative linear relationship, correlation. It's going down from left to right. That's why it's negative. And so what they do is they give us this line here. They give us an equation of a line. And this equation models this blue line right here. So it's y equals negative 1.25x. So that negative 1.25, that's our slope, right? Think about y equals mx plus b. And then 97.5, that is our y-intercept, right? And if we followed this line and kind of made it cross the axis, it would cross at about 97.5, which is, below 100, above 90, somewhere around here. And that makes sense, right? You can see that. Hopefully that seems pretty clear to you. So the hardest part about this is just trying to figure out what are they asking us. So this first question, it says, for an increase of 1 degree Fahrenheit, what is the predicted decrease in the monthly heating costs? Well, I think the easiest way to think about this is ask yourself, first of all, if the average monthly temperature was 0, okay? So that means that my x value is 0, because that's average monthly temp is on your x-axis. If I made that 0, what happens here is this whole term with the x on goes away, right? Because 0 times anything is 0. And then you're left with, for your y value, you're left with this 97.50. So that's saying that if it were 0 degrees, your monthly heating costs, according to this model, would be $97.50. All right. Now, if I do an increase of 1 degree Fahrenheit, it would be, okay, so I'm saying now if it were 1 degree, and I put 1 in here, what's going to happen? Well, you should hopefully be able to see that if you multiply negative 1.25 by 1, it means that we're going to have negative 1.25, right? There's a reason I use 0 and 1 here. And then I would subtract that from this. So if you put 2 in, you would have 2 times negative 1.25. So each time you go up a degree, your cost goes down by a factor of $1.25. So in other words, that's our slope, right? For an increase of 1 degree Fahrenheit, what is the predicted decrease in the monthly heating costs? If they're asking you about the unit rate, guys, it's your slope. And the slope is the number in front of the x. So if you can remember that, you will always get this one correct. Slope is the number in front of the x. All right, letter B. What's the predicted heating cost for a month with an average temperature of 0? We just did that one. If I put 0 in here, it gets rid of this term, and it leaves me with $97.50. Now remember, this should make sense to you, and it does make sense that the most expensive rate would be in the coldest month. All right, now, this last one, what's the predicted heating cost for a month with an average temperature of 45 degrees Fahrenheit? So you're not going to look at the graph for this and go up and find it. That's going to kind of tell you approximately where it's going to be, but we're going to use this equation of this line here to fit, and we're going to put 45 in for our x. All right, so I'm going to go, all right, I'm going to go negative 1.25, my parentheses, right, that's x, that's how we substitute. Put in 45 and then close my parentheses, and I'm finishing writing this equation out, so I'm going to add 97.50 plus 97.50. And what this does then is it multiplies this, and then it's going to take that number and it's going to subtract it from 97.50. And we get 41.25 as our answer. And let's check that. So 45 degrees, if I go up here, yeah, that puts me a little bit above 40. That looks solid. So let's go for that. And let's check our answer. Let's see if ALEKS likes our answer. And of course, it does. So again, hope this is helping. Next video, we'll start with problem 6 and see where we get.